So we have said today we are going to learn about two algorithms. First is the searching algorithm, and the second is the sorting algorithm. So search, I think it is very easy for all of you to understand. For example, we have several, like 22 students in this class, and we have a list, right? We have a list in this name, and then I would like to search like Fulan, or I'd like to search a student number like 2021030290. Then, if we are human beings, we just give a glance and we find out the one we are searching for, right? But how computer accomplish these tasks? Because the computer cannot, or it doesn't work as our human being's brain. So how the computer can accomplish the search task and find out like Fulan in this list? How does it do? So it's supposed to do this by one step, right? So the first very easy, the most fundamental, very easy algorithm, we call it sequential search. So a sequential search examines each item. Okay, the keyword is it examines each item. So it looks from the first one. It looks from the first one. If this Fulan, it checks. It no, then it looks next one. If this Fulan, and no, then check the next one. Use the if else, the decision block. Use the decision logic structure in our computing algorithm. So basically it examines each item. All the items are supposed to be examined. And how does it examine? It examines it in turn, okay, in turn, one by one in turn. And each time when it examines it, needs to compare it to the one we are searching, right? That's what I did in the list. So then it do a decision, right? If it matches, then we find the item. This defines how or when the task is finished. So we know when we do a cook, we're supposed to know what dishes you want. So this is the results we want, and we know when this came up, the program is supposed to be stopped. It ends, right? So we can have an if here. If this matches, we found it, and the program is end. And if not, then what you're supposed to do? That is go to the next one in the array. Okay, so this defines in this decision two branches for different operations. So we need to stop, right? Either we have found the item. This is one possibility. We find this item. Another possibility is that the one we search is not in the list. For example, if I want to search in this list, search like Yiru, that's not named in this list. So if I search one by one, it will not end. If I said if you found it, then you can end. When you never accomplish this, never satisfy this condition. So we need another end condition. That is, if we looked at all the items and not found a match, then we also end. Okay, so this is end condition. So we can find if we think in the computer way, we need to define a starting condition, and we need to define an end condition, and we need to define during it what we're supposed to do. Okay, so basically it is a loop in this sequential search, and it has two ending conditions. In the loop, we do this. We do this. Okay. So if we write down this sequential search, it's very easy to understand, but it will write down it in the pseudocode. is supposed to do like this, okay? So firstly, we need some flags, like the position flag, like the found flag. The position flag define which one in the list you have already searched. So we set it to 0 from the first one. In the computer, we always set the first one. Usually we set it to 0 instead of 1, okay? So we set the position from 0 and we add it to 1, 2, 3. So each name in the list has a position and it is defined, and we use this flag. We can check different locations. So firstly, we need a flag about the position, and then we need a flag about is it found or not, right? Because in the end condition, we finally we need to stop. So we need a flag to make sure if these conditions are satisfied or not. If it's satisfied, then we end the program. So we need to set another flag. And then we have said that this is a loop. So in the pseudocode, we use while to represent this loop. And we list the end conditions in this place to determine when we need to do the followings or when we need to go out of the loop. So the condition is if the position is smaller than length and not found the solution, then we do the followings until the position is larger or equal than the length. That means we have checked all the lists. That is when the position is larger or equal than the length. The length is defined. The length is defined first before the program, okay? So this is the first condition. The second condition is it is found, right? So then if this conditions is satisfied, that is represents we didn't find the solutions, what do we supposed to do? We do the if else decisions. Here we mentioned that, right? We have if or if not. Then we check if the number equals search item or not. So the position represents which one you are searching. So then we compare it. If true, then we set this flag as true, and this will get out of this loop. And else, just add the position, and position equals position plus 1. Move the position to the next one. So this is the pseudocode about this sequential search algorithm. So if you noticed that here I listed that sequential search is for an unsorted array. So sorted array and unsorted array is supposed to be in this array and in some order, in descending order or ascending order, both okay, just in some order. If it doesn't have any order, then it is unsorted array. For example, such kind of order can be any possibilities. Okay, for example here, so in the Chinese character, we can have pinyin. So we can have from A or character or alphabets from A to Z. That is some kind of sort. So here is obviously it's obviously not a sorted array. So